Okay, for those of you who didn't finish the investigation in class, here is a run-through of the investigation with my triangles, and you're going to do it with your triangles. Okay, so first of all, what do you notice about the two angles measured? Let's measure these two angles. What do we get? Well, for these triangles here, what we get is about 20 degrees for the smaller one, and we get about 38 degrees for the bigger one. So you might notice on your case that your two angles have one angle 2 times bigger than the other, okay, which is why we're doing a derivation of the double angle sine and cosine relationships. Okay, now let's measure the others. So this one, let's say, is 8.6 centimeters. This other one is an identical 8.6 centimeters. This bottom radius is 9.1 centimeters. So of course this top radius here is also 9.1 centimeters, because you can see that both radiuses, they're both radii of the semicircle. This vertical leg is 5.3. and this horizontal leg is 7.3. Okay, so we have everything measured here. And now we're going to use these measurements. We are first going to use these numbers that we got from our measurements to derive the double angle sine identity, which is this one here. Okay, and first thing it tells us to do is it tells us to find the sine of triangle 2. So where is triangle 2 again? Okay, here we are. Triangle 2 is this triangle here of 38 degrees. So the sine of this triangle would be sine of 38 degrees is equal to 5.3 divided by 9.1. So here we have it noted here. And so now it says to find the triangle 3 sine. Let's see what triangle 3 is. Triangle 3 is this big triangle here. So the big triangle is it would be sine of 20 degrees equals 5.3 divided by 8.6 plus 8.6. So it would look like this, right? 5.3 divided by 8.6 plus 8.6. And you might be wondering why I'm not adding together the 8.6's, but you'll see that in a minute, okay? And then finally, triangle 1. We're supposed to find the cosine of triangle 1. So the cosine of triangle 1. Triangle 1 is this triangle right here. And one thing that's tricky about this triangle here is, do you see how it's actually a right triangle that's kind of upside down? This is the right angle of triangle 1. So if we're looking for the cosine of triangle 1, we're going to find the adjacent, which is this top one, which is 8.6, over the hypotenuse, which is the bottom one, which is 9.1. So it's going to be so it's going to look like this. Cosine 20 degrees equals 8.6 divided by 9.1. Then we're supposed to solve for the opposite here. And the opposite here would be the top one, right? Because it's opposite over hypotenuse. And then here we're supposed to solve for the hypotenuse, which is the bottom here. So let's do that algebra. So first we're going to solve for 5.3. So we're going to multiply both sides by 8.6 plus 8.6. So we're going to have 5.3 equals 8.6 plus 8.6 times sine of 20 degrees. And for this one, we're going to have, we're going to solve for 9.1. So to solve for 9.1, let's cross multiply. 9.1 cosine of 20 degrees is equal to 8.6, and then divide both sides by cosine of 20 degrees, and we'll get that. Okay? So now that we have those two relationships, we can see that we have an expression to put in for 5.3. We have an expression to put in for 9.1. Hey, what do you know? Look at that. We have 5.3 and 9.1 here. So let's substitute those. So we're going to have sine of 38 degrees is equal to 8.6 plus 8.6 times the sine of 20 degrees. And then we're going to divide that by 8.6 divided by the cosine of 20 degrees, right? Because 9.1, we substitute in that. Okay, now we can see that we got 8.6 plus 8.6 divided by 8.6 is actually 2, right? So now we have 2 sine of 20 degrees divided by 1 over cosine of 20 degrees. Okay, then we're going to take this bottom fraction here, and we're dividing by a fraction. So remember, when you divide by the fraction, it's the same as multiplying by the inverse of the fraction. So we're going to have 2 sine 20 degrees, and we're going to multiply by cosine of 20 degrees. So that's going to be finally equal to 2 sine cosine, and there we go, right? We have the sine of 38 degrees, which is the double angle, is equal to 2 sine of 20 degrees times cosine 20 degrees. Okay, so we've just derived this relationship here. It's a lot easier to derive these relationships with numbers instead of variables, right? Okay, let's now do the double angle cosine identity derivation. So first it says, give us the triangle 1 cosine. So let's find the triangle 1 cosine. Triangle 1, remember, is this upside down triangle here. Okay, so the cosine of this would be 8.6 over 9.1 for the hypotenuse. 8.6, 9.1, and the cosine of 20 degrees. Then it says to solve for the adjacent. The adjacent is the top, so we're going to solve for that. We're going to have 8.6 equals 9.1 times the cosine of 20 degrees. Oops, I forgot to do the first one. The first one, step 1 says to find the cosine of triangle 3. Triangle 3 is this big one. So the cosine of the big one is going to be 9.1 plus 7.3 divided by 8.6 plus 8.6. And that's going to be the cosine of 20 degrees also. Okay. So you can see I wrote it right there, right? Now I'm going to look at number 2. I did it all out of order. Sorry about that. Triangle 2. Now I'm going to find the cosine of triangle 2. Triangle 2, remember, is a small triangle here. The cosine of this one would be 7.3 divided by 9.1. And this angle here, of course, is the big angle. It's 38 degrees. Now let me show you what I wrote here. There you go. Now, just let me erase that. There's 7.3. Okay? Alright, now we're going to solve for the adjacent. The adjacent is that one. So we're going to have 7.3 equals 9.1 times cosine of 38 degrees, right? Okay. So now we have 2 expressions, one to substitute in for 8.6, the other to substitute in for 7.3. And what do you know? We have some places in our equation that have 7.3 and 8.6. We have 7.3 there, we have 8.6 there, we have 8.6 there. We can substitute in for those. Cosine of 20 degrees is equal to, and then we leave 9.1 because we don't have any value to substitute in there. For 7.3, we're going to substitute in 9.1 cosine of 38 degrees. For 8.6, we're going to substitute in 9.1 cosine of 20 degrees. Plus, and you notice we have that twice. So some people might say, oh, if we have 2 of these identical terms on the bottom, we can combine those and put 2 9.1 cosine of 20 degrees. Okay, and on top, maybe we'll factor out 9.1 to simplify. Cosine 38 degrees. Okay. Oh, look at that. We can cancel out the 9.1s, right? So now on top we have 1 plus cosine of 38 degrees divided by 2 cosine 20 degrees, and that is equal to cosine 20 degrees. And then here it says solve for the cosine of the larger angle, which is 38 degrees. We're going to isolate cosine 38. So the first thing we're going to do is multiply both sides by 2 cosine 20. and then we're left with this. And then we're going to subtract 1 from both sides. So we're going to get 2 cosine squared 20 degrees minus 1 is equal to cosine 38 degrees. Okay? And if you take a look and compare this with this, we actually have found that the double angle is equal to 2 times the smaller angle, 2 times the cosine squared of the smaller angle minus 1.